vocabulary words today. So time it takes one. Okay, let's see what we got. Time it takes for one cycle to complete. So time is a period. Time it takes for one cycle to complete. We're going to be talking about that today. The period. All right. So it's how long for one wave to go by. All right. So that's the time it takes. Two waves that stand same amplitude and same frequency. That's a standing wave. So if you're following along with me, a standing wave is a wave that one that goes forward, goes one direction and comes right back, the same intensity, and it's a standing wave. Two waves that kind of have a. So we'll see a better picture of it when we get into the assignment here. Let's see. Okay. Waves that need a medium. Okay, so waves that need a medium are mechanical waves. So mechanical waves are a type of wave like sound waves that need something like air, water, um, anything with matter in it. It does not go through a vacuum of space. Disturbance that transmit energy from one location to another without transmitting matter, that is a wave. Remember the ping pong ball just bounced up and down, up and down. The wave energy goes through, but the particles bump into each other, but they just bump and then they go back to their original place. Wave produced by vibrating object, that would be sound waves. So vibrating objects like a tuning fork or a guitar. Vibration of a wave and it's perpendicular. So we're going to be talking about this, but you probably have seen these. These are transverse waves. All right. So, and then the waves that are in the same direction are longitudinal. Sometimes they call them compression waves. And can travel through empty space. That is your electromagnetic wave. So that's light. So if we didn't have light coming to us, we would not be here. Number of cycles that occur in 1 second, that is frequency. Tell me when you get done with that. Hey, Nevaeh. Hey, it's Ethan's birthday. Did you say good morning? Happy birthday. All right, so tell me when you get done with that. Finish. Thanks, Madison. So submit answers. You can see this. I'll try to make this a little bigger for you guys so you can see it. Come on, make bigger, not smaller. Come on, bigger, bigger. It's fighting me. It's fighting me. Makes it. I try to make it bigger, and it makes it smaller. Oh boy. So, all right. So I'm going to get my head out of there so I can see. You can see it a little bit better. All right. So tell me when you get done. Tell me when you get done. I'm doing good, Madison says. I'm doing okay, says Nevaeh. You can if you want to, Ethan. Yeah. Yep. I mean, there is that one. I was just doing this as practice so that you guys can do it. So there is a vocabulary one in Canvas. So let me submit the answers here. Did I get them all right? Hope so. I made it. Today is a pretty good day. Look at me, got all of them right. Took me $3 3 minutes and 39 seconds. All right, so we're going to do a Nearpod today. Okay, so I'm going to give you this Nearpod link here. All right, student live participation here. So let me clean up the chat here and give you this link. We had about 10 people there yesterday. Probably won't get that many today because there you go, Nearpod, because we only have 26 people. Thanks, Ethan. I appreciate you giving that little shout out to people. Get in there, ladies and gentlemen. So we're talking about waves because it's important to the planet, all right, and the vital role for transporting energy around the globe and the coastline. I talked about this yesterday. So that's how places keep warm. I live in Michigan, and you guys have Lake Erie by you as well. And that, if you live by Lake Erie, it's a moderating part of the of where you live. It's cooler by Lake Erie if you live close there. And then because of the water that circulates, the waves that move the water around. You live more toward Kentucky. Okay, there's no big water source there, is there? Yep. A lot of rocks there, though. Beautiful country at the bottom of Ohio. Ohio is pretty flat until you get to Columbus and then Hocking Hills and that area there. You get there, and there's really pretty um, rock formations. All right, so what we're going to do is we're going to do a Nearpod. We're not going to be, and I'm going to show you a lab here. All right, so if you got in there, you've never been to Hocking Hills, you should take a look at that. Okay, so if you guys will do this, let me see if I can make this bigger. There we go. All right, so if you look at the wave, see how many people I've got in there. I got Sean, Ethan, Kobe. Good morning, Kobe, and Claudia and Cameron. Thanks, guys. If you guys can get in there, the blue dot makes it to shore. So if we take a look at the image here, so here's the video. And here's my voice. And I'm circling the blue dots so you can see they're just wobbling back and forth, right? So it does not make it back to the shore, does it? Nope. Does not make it back to the shore. All right. So that is a makes it to shore. That's false. Next. See if I get next. Most waves travel through matter. Science says the waves propagate, move through a medium. Select all that are mediums. So air is a medium, liquid is a medium, and solids are mediums. Vacuums are not mediums. There's nothing in the vacuum of space, but light can travel through that. Mechanical waves need to have a medium like air, liquids, or solids. All right. When waves travel through a medium, it causes particles to oscillate. All right, oscillate. That's what we want to call it. Oscillate. And the oscillation is kind of a up and down motion, but it's kind of more circular than up and down. All right, the movement of a wave is actually a movement of energy, right? So this energy, you disturb the water, and energy is the disturbance there, right? All right, so guys, let's leave the chat till the end of the hour here. We'll have some time to talk. So if we could keep the chat on what we're doing here, I'd appreciate it. Thank you much. Waves transfer energy and not transfer matter. That is true. Saw that from the ping pong ball in the water. The ping pong ball just bobs up and down. It's true. Energy only. All right. All right, Nevaeh, how are you guys doing? Let's keep the chat. All right, thanks. And Nevaeh, are you in there? You working on this one? Let's see if Nevaeh's in there. Come on. Hey, Nevaeh, you got it. Great. All right, so got 4 out of 5, 3 out of 5, 4 out of 5. Which one did you guys miss? I can't tell you. All right, let's move on. So what is a wave? So these are representations of waves. And depending on what we're going to do is talking about the parts. So there's an exit quiz on that. Remember, we talked about electromagnetic and mechanical waves. Today, we're going to be talking about mechanical waves. All right. Let's see here. Okay, so we did this yesterday. Let's do it again here. So waves transfer energy. All right, there are two different types of waves. They're mechanical and they're electromagnetic. And mechanical needs a medium like air or gases, liquids, or solids. And electromagnetic does not need a medium. And the light is an example of electromagnetic because it goes through a vacuum. And sound is an example because you cannot yell and scream in space. You might want to. You might be so happy that you want to. Okay, give you a second there. Give you until 9:18 to get that labeled there. You have extra credit for today if you are working in the class here. Finished. Ethan's finished. All right. Let's see what you got. Okay. All right. Claudia's work done. Cameron's almost there. Madison's there. Nevaeh, Sean's there. Kobe got it right. Thank you, Kobe. Cameron's almost there. 9:18. Okay. One more, about 30 seconds. If you can get in there, hop in there, that'd be great. All those new people that haven't got in there, right? Carrie, Jaleel, Grace. Let's see. Ethan's your birthday. You are gonna get some extra points because it's your birthday. I wonder if Savannah Brewer is in here. Savannah Brewer, nope. Savannah Shepherd. Why is this not in alphabetical order? What I was looking about. There we go. That's better. No, they don't still have it. They don't have it in alphabetical order. I think it's on when you came in. All right. Hey, Sherelle, Naisha, how are you doing? Let's see who else haven't I talked to. Lexi, good morning. Jada, good morning. Dublin, good morning. All right, so we got everybody here. Is that it? Okay. So there are 3 types of mechanical waves. Make sure you're paying attention. There's an exit quiz at the end of the hour. We're going to talk about transverse waves, longitudinal waves, and standing waves. So I'm going to go over to this one here. Let's see, my intro. Let's see here what go. I'm going to go. Okay, so that doesn't seem like that's the one. It's not giving me the pictures I want. Oh, here we go. Transverse waves. Let me go back over here. Transverse waves go in the particles. The medium move up and down, and the direction of the movement is to the right or left. So the particle, the wave bobs things up and down. The energy goes this way, so it's perpendicular or to the right or 90 degrees to the direction of the wave. Okay, so that's a transverse wave, right? And you've ever had a slinky, you can see a transverse wave by just shaking it up and down, making a little bump in it. That's a transverse wave. If you've ever taken a jump rope, tied it to something because you don't have 2 people and you can make a wave. So the person disturbs or shakes the rope up and down, a transverse wave moves through the rope. The particles in the rope move up, left or right, while the particles in the wave move up or down. Okay, so the wave moves to the left or right, particles move up and down. So that's a transverse wave. Longitudinal waves, on the other hand, are the particles of the medium move in the same direction as the movement of the waves. You can see in this thing here, the wave starts at the left-hand side and goes to the right and then kind of bunches things up. So we'll be talking about the bunching. They have different vocabulary for the compressions and rarefactions that they have on those. So a slinky, if you've ever done a slinky, I used to do that in science class. We used to have lots of slinkies. They always get tangled up though, and that's awful. Slinky is disturbed in longitudinal. The wave moves to the right or left, and the slinky and compressed and spread out. So they go in the same direction, right? So the particle motion and the energy motion go in the same direction. So that's longitudinal, and it's a long wave. That's how I think about it. Transverse is up and down wave. okay? And here is a standing wave. So if we were taking, so a standing wave, the wave looks the same, but it comes back in the opposite direction. And there is, so if we look at the picture of it, if we were taking a picture over time, a time lapse picture, we'd have this up and down motion. We'd have one going there and one coming back. And if we took a stop picture of them, they would look like they were on top of each other. Two waves in the same amplitude. Amplitude means how high it is, how much energy it is, and the same frequency, which means how fast it's moving per second. All right, so let's do this particular one here. Let's go on to the Nearpod one. All right, so let's see if we can. All right, so let's do this one right here. Okay, so we're going to take this mechanical waves here. It does transfer energy through a medium. There's a transverse, longitudinal, and standing wave. So I'm going to help you with the standing waves. This is what the standing wave looks like. Okay. And two waves in the same and opposite, two waves, same size, moving opposite direction. That's what I call it. So if you guys can figure out where this one, what does this one look like? And this one. Put those in those pictures there, and then do the definitions underneath. Give you a couple minutes, 9:23. Let's make it 9:25. All right, so transverse wave. Let me go over here. I will help you with that. I'll do this. How's this? I'll go here. Okay, so this one, so transverse wave, remember it looks like this. The transverse wave the wave moves left to right of the particles and then move up and down. So it's an up and down motion. That's the transverse wave. Okay. The longitudinal wave is like that slinky there. The particles, the wave moves to the left or right, causing the slinky to compress or spread out. It moves in the same direction as the energy. So the wave motion is the same direction as the energy. All right, if we were doing earth science, we would be talking about earthquake waves, and earthquake waves can do both. They can have compression waves like longitudinal waves, and they can have transverse waves that go up and down. And remember, standing waves are the ones, two waves of the same amplitude moving in opposite direction. So it basically hits the wall and then comes back the same direction. So hits the wall and it's 9:25. Okay, let's do the Nearpod thing. Go back over here, see how you guys are doing. Everybody got it done? All right. Let me get Claudia to, let's go take a look at this. All right, Claudia, yeah, transverse wave is that up and down wave. The longitudinal wave is like the slinky, perpendicular to the direction and same direction. Right, so if you got this, if you need to make a correction on that, do that. Thanks, Claudia. Let's go back to this one. I'll tell you. So this one is the transverse wave, right? Longitudinal wave looks like this, compressions, and so it's a slinky, and then same direction of travel, that's the longitudinal wave, and then perpendicular going up and down, the wave's going to the right, and then the particles are going up and down, up and down. All right, thanks, Kobe. Cameron, thanks. Nevaeh, thank you. Sean, and let's move on. All right, so wave properties describe how waves move and the waves look like. Some properties are amplitude, wavelength, and frequency. So we'll be going into wave speed tomorrow. Just want to let you guys know that tomorrow I will be in class at 9 o'clock for credit recovery. So if you're doing credit recovery, make sure that you get in there Hey, Aaron, I see you. How are you doing? Alariana, Angelina, good morning. Annabella, Brianna, I didn't say good morning to you this morning. Hey, Chloe, Derek, got some new people that came in. Who else came in? I think that's what I see. Yep. Okay. So let's take a look at this. So here is the wave properties. Okay. So if we can, this is a transverse wave. And a lot of times if we're using, if we're doing something and we're making drawings of it, so the best visualization is to draw a graph. So the horizontal axis is the x-axis. It measures time, so distance, and then the y-axis measures height. The horizontal axis is the equilibrium or rest position. So we have the rest position as the line there. Points along the x-axis represent rest or equilibrium. Okay, so these are the things that how we label these. Again, if it's a longitudinal wave, we talk about different parts. All the way as the wave moves in the area of a medium, particles in the medium move upward from the rest position. The maximum displacement is called the crest. So the height is the crest. Right, it's crest of a wave where you'd probably be. I don't know. I'm not a snowboarder, not a snowboarder. I'm not a um, surfer, so I don't get out in the water. We're pretty far from that. The disturbance moves away from the area. The particles move downward past the rest position. That's the trough. So a lot of times you think of the reason they call it a trough was way back when they were feeding animals in the trough. You know, everybody had a horse, I imagine. So they have a place where they put water or feed called the trough, the low point. The maximum displacement is called the downward displacement is called the trough. And then the rest point is the halfway point in between. All right, so those people that are working on this, so go ahead and put the trough, yep, on a skateboard, right? Yeah, I understand that. Okay, so where is the trough? Remember, that's the low point. There's three spots here: the low point, high point, and the rest point. So this is the rest point in the middle. Okay, crest and trough. So let's go over here. I'll give you guys an opportunity to look at this. Oh, I signed out. I better sign back in. All right, sign in. Sorry about that. I got up too early this morning. Okay, let me go through this again. All right, so let's do this part here. Okay, right here. So you can see the high point is the crest, the low point's the trough, and rest is the equilibrium point in there. So if you're working on the Nearpod, there's a quick look at what's going on there. Give you another 30 seconds or so. Let's see what you got here. 3. All right. Let's take a look at Kobe's. Good job, Kobe. The top is the crest, the bottom is the trough, and the rest point. Very good. I lost a few people here. Cameron may have walked away or his computer is lagging. Sometimes that happens. All right, so let's move on. There's Ethan. Crest, trough. And again, you get your notes. If you look at your notes, if you go back here to your notes, they are ready right there in that part. They are labeled for you right there: wavelength, amplitude, trough, crest. So it's labeled all there for you. So if you want to put those in for offline tracker, that you did some notes, took some notes for this offline, I will give you credit for that. All right, go back to the Nearpod. All right, we got Ethan. Great job, Ethan. I'm glad you got there. Wave properties. A wave cycle is one complete path of a wave. A complete path is from crest to crest, trough to trough, is called the wave cycle. So here is one cycle, one up and one down. So this one happens to have two cycles. So one cycle is one up and one down, and the wave cycle for here. So we have two cycles in this graph. Okay, the amplitude is the height of the wave, the maximum displacement, or the maximum displacement down. Either way, you can measure this. So the wave height in meters, this would be about 1 meter. For mechanical waves, amplitude is related to the energy. Waves with higher amplitude carry more energy. So low amplitude, low energy, high amplitude, high peaks, higher energy. It sounds pretty predictable with if we're thinking about surfing or going down a hill. All right, so the amplitude, to determine the amplitude of a wave on the graph, measure the distance from the equilibrium to the top of the crest or trough. Do not measure the distance from the trough. So just from the rest position to the top. All right, wavelength is one complete wave. So you can either measure from any point, you can measure from the crest to crest, trough to trough, or the point where it hits the rest position to the other point. Okay. And we measure this use the Greek letter lambda. It's like an upside down Y. Wavelength is measured in meters. To determine the wavelength, measure the distance to corresponding points back to back. So here, this one is 2 meters, starting here, 1 and 3. So that's 2 meters. Okay, probably an easy way to do that. All right, so let's try and sketch. This is the tough part here. Okay, so I've given you, so I've made these 4 centimeters, and the wavelength is 4 centimeters. Amplitude is, that should say 2. Sorry, it should say 2. Let me do this. It's going to be 2 right there. This is supposed to be 2, and the wavelength is 4. So what I did is I gave you some dots. Okay, so what I did is I went halfway. So I know that it's 4 centimeters wide. So I put a dot right here and a dot right there. And it goes up 2. So I went up 2, and it has to come down and then go up. Okay. And you can be as messy as I am here. So I'm trying to do this with my mouse. It's not very good because I keep sticking on something here. So this is how I do it. Not going to be part of the... See if I can draw it better with my finger. So 1. You just can't see my finger very well. Okay, so if we were measuring wavelength, we could measure wavelength from here. From here to here. Okay, 1, 2, 3, 4. So this is 4 centimeters. We're using centimeters. For measuring the amplitude, it's just the height from the rest, and that's 2 centimeters. Again, they want us to do it in meters, but it's easier to measure this as, we could have make those meters as well. So the amplitude is the height, and that's 2 centimeters, and the wavelength is 4. And we use this lambda, upside down Y, to say that's the wavelength. So like I said, gave you some dots to try it out. Good job, Claudia. Thanks, Kobe. Right, so Yeah, you got it. And that's how you're not going to be one of those things where you're going to be measuring the wavelength from um, already made waves. Okay. All right, so let's do this together. So what you're going to do is you are going to put the answers, use this measuring device. You have to go to this website. Okay. Hit next. Take the ruler and go from, I'm going to go from crest to crest. I had to cough a little bit there. So this first one, if we look at this, it looks about 4 units. Take this one, they are closer together. This looks like it's about 2 units. And then if we go from crest to crest here, it looks like 1 unit. Let's check your answers. I did good. So what you're going to do now, go here, and then go ahead and put the numbers in. This was 4, 2, and 1. So that's how you measure them if we're measuring these out. 4, 2, and 1. Hey, Madison, good morning. I see that you made it. 4, 2, and 1. So if you saw mine, and then if again we went to the wavelength thing here, you can measure these approximately using the ruler here. Drag the ruler over the waves, and you can find the wavelength. Okay, 4, 2, and 1. 4, 2, and 1. Thanks, Kobe. Thanks, Madison. Madison's. The Maddie and the Madison. Okay, so frequency of a wave is the number of times a wave cycles in 1 second. So this one is the frequency. So here's 1 second here. And you'll notice that you have two waves that made it in 1 second. 2 waves. So here's one wave, and here's the second wave. So the frequency is measured in this idea of hertz. All right, so 2 waves per second is, we call it hertz. If you look at the radio dial, they have things in hertz. So if we take a look at this website here, let's go and let's add the rulers and the reference line, the timer. Okay, so, oh, here we go, oscillate. All right, so this is an oscillation. It's automatically, if I were to bring this down to amplitude of 1 or 0.2. Okay, so every line here is 0.2. So I'm going to, so right here is just 0.2 centimeters, right? And I'm going to move this up to that rest point, and you can see it's got getting to 0.2. So that's the amplitude here. And my frequency, you can see if I lower the frequency to about one hertz, so that's 1 cycle, 1 wave per second. So let's see if that works out. So I'm going to count here. how many times this is bobbing up and down. And I put a timer on here. So I'm going to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pretty close. So I used 10 seconds and I counted 10. So that would tell me that I did, the frequency is 0.99 or one wavelength, one wave passing every second. One wave passing every second. So if I go to 2 waves passing every second, I would use the timer again and I will count to 10. I will count how many in 10 seconds. Let me see if I can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, so I did 20 waves in 10 seconds. So that's 2. So 20 divided by 10 gives me 2 waves per second, or 2 hertz. Okay, and I can adjust the amplitude. Now notice the amplitude goes higher, but it does not make the frequency go higher, right? So I can make the energy, this is just a more energetic, more energy in the wave, but it's still 2 waves per second, 2 waves per second. So here I've got 1 centimeter. You can see that the height of this is 1 centimeter, right? At the top highest part or the lowest part, and that's 2 waves per second. So that's how this works out. Go back to Nearpod. Where are you, Nearpod? Okay, nope, that's not it. Nearpod. Okay, so let's go back over here. So that's just something you can play with to see this. So frequency of the wave count and the number of wave cycles completed in 1 second. Be sure the x-axis is measuring time. So here this is 2 hertz. So we have 1. So this is half a second, 0.5, and here's 1 second. So 2 cycles in 2 hertz. That was the demonstration there I was just showing you. All right, so there are important properties of the wave. They are period and velocity and speed. So these are one of the things that we're going to be doing tomorrow. And I will give you a heads up on this. So this one, a period is how long it takes for 1 cycle. Okay, and it's in time. So this period, a period is, for this one, is 0.50. Okay, so the period here is this complete cycle, this complete up and down, took 0.5 seconds. Right? Now, when we're looking at the frequency, there's a relationship between the two. The frequency is 1 over, the period is 1 over the frequency. So let's go back to what we did before. So we had 2 cycles, so 2 hertz, 2 cycles in 1 second. So that, if we put frequency underneath there, then this is my period. Period is 1/2 or 0.5 seconds. Okay. And then if we take the period 1 over 1/2, remember when you do 1 over 1/2, you got to flip and multiply. So this gives us 2 hertz. So there is a relationship between the two. Okay. So let's do this real quick. We're going to take a quick little quiz, exit quiz. We got about 15 minutes left, less than that. Let's do this real quick. Let's go here. I'm going to stop sharing. Thanks for you guys for participating. And again, this is going to be a poll question, so get as many people as I can in the poll. We have 32 people. Right, so here we go. A, B, C, or D. All right, what letter is amplitude? A, B, B, C, or D? Amplitude. What letter labels the amplitude? A, B, C, or D. So I've got 7 people. We could get more. Aaron, Aluriana, Angelina, you guys could get in there and put some votes in. I appreciate it. Cameron, thank you for working today. Claudia, thank you. Derek, Devin, Dominic. Hey, Dominic, long time no see. You back from testing, looks like. Or you're maybe, hopefully, not testing and doing the same time. All right, Kobe, Alexi, if you guys can get in there, Micah, Naisha, Naraya. Good morning, Naraya. Savannah, Sherelle, Sean, Trace, and Vivian. Okay, so I don't see Aaron, Illyriana, Angelina, and Abella. If you guys could put a vote in there, A or B, C or D. Oh, I know what I forgot to do. I'm going to go over here, see if I can get let me go this way. I'm going to clear this out, get my Nearpod. Yes, leave this session and I'll get a name here. Let's see if I can get a name of person here. Okay. Live participation. Yes. Resume. All right, so let's take a look over here. Oh, well, are you here? Put your name in the private chat if you are here. You are here. Let's see what we got here. Sherelle. Okay, so publish the poll. Okay, so half and half. So B is the correct one. A is the top, but the B is the measurement of the amplitude. B is the measurement of the amplitude. Okay, let's do the next one here. All right, what letter represents the crest? What letter represents the crest? And I'll do another name drawing here. Did Sherelle say anything? Nope, she did not. Okay, let's do the name drawing here while we're doing this. Share. I don't think Noah's here today. He must be testing today because he's usually here. Okay. All right, so let's try another one. Let me go to the slot machine thing. Hayden, I don't think Hayden's here either today. Okay, let's go with the switch to slot machine. Switch to airport lounge. Okay, let's do this. Put your name in the chat, the private chat. Lexi's here. I'm sure she's here today. All right, Lexi, put your name in the private chat there for your extra points. All right, so let's do what the chat looks like here. All right, label the crest, publish the poll. Thanks, Lexi. All right, so it is A. You're right. Crest is A. The B is the amplitude. C is the trough. Right? D is the wavelength. Okay, so see what we got here. All right, what is the trough? Let's do this one. Okay, didn't I publish? Okay, yeah. We are, what's the trough? We've already used A and B, so you just have C or D to do here. C or D. We've already used B. That's the amplitude. A is the crest. Let me get the name of a person here. Let's see if we can do this again while we're getting that on there. Name of a person. All right. Dominic's here. Hey, Dominic, put your name in the private chat for a point. I'm writing these down here. Now we got Lexi. We got, why did they not showing it? Dominic. Yes, Dominic says so. Dominic and Lexi. Let's do this again. One more time. Sherelle. I've been Sherelle before. Well, hopefully she gets back here to us. Okay, so let's go back to closing this out. All right, publish the poll. And most of you said C. You're correct. C is the trough. All right, let's do the next one. What's the wavelength? Only one letter left on this one. What's the wavelength? We've used A, B, and C, so there's only one letter left, right? One letter left. And I will do the drawing again while we're getting everybody participating in here. Did I get Shrell? Nope, I didn't get Shrell. Okay, let's go again. Jasmine, is Jasmine here today? No, no Jasmine. I'll try another one. Got Lexi already. Dominic again. Did I get another name here? Nope, got Noah last time. You think they're all right. These guys are lucky. Try some different. Cameron, Cameron's here. Cameron, put your name in. Maybe not. Maybe he's, oh, he did. Oh no, he's still here. If you put your name in the private chat there, you have an extra point. Let's go back to the publish the poll. Okay, D. Some people put 3. C, which C is the trough. Wavelength is the measurement from one side to the next, right? Did I get Cameron? Nope, I did not get Cameron. All right, I think that is okay. So we are done for today, ladies and gentlemen. See me at 3 today to go over worksheet 12, assignment 1, and worksheet 12, assignment 2. I did email you guys if you didn't have those done. We'll also go over an old assignment to catch you caught up. So these are last week's assignment. Did email everybody about the if you're missing that assignment or you have less than 15% or 15 points. So come over and either go ahead and fix it yourself or come and see me. We will be going over that today at 3. Tomorrow, it was Wednesday, 9 o'clock. I'll be doing credit recovery tomorrow at 9. So if you're interested in getting a little head up on credit recovery, 9 a.m. tomorrow, Wednesday. So there are only 3 modules, and those modules usually I've had really good luck. People have been passing the pre-tests or the post-test without doing the assignment. So you guys are pretty smart getting through those. So those 3, I had somebody finish. They started the credit recovery 2 weeks ago on a Wednesday. They got done on that Wednesday. They probably spent less than 2 hours. So if you're interested in getting your credit recovery done, see me tomorrow at 9. I will email you guys as well. All right, guys, let's say goodbye. All right. See you, Nevaeh. Bye, Lexi. Bye, Jaden. Bye, Madison Moore. Bye, Dominic. You have a great day. All right. Any questions? Let me know.